So in this video, I again have two practice problems that are focused around protecting groups. Uh, to get into this first one, I was able to do it in 5 steps. So if you come up with something that's 5 steps, you might have something that I have as well. But go ahead and give it a try on your own real quick, and then we can work through the synthesis together afterwards. Okay, so I'm recognizing that from our reactant to our product, we are keeping our amine protected. Doesn't look like we're going to be doing anything other than protecting it in this problem. And so I'm going to immediately start by protecting it with that generic diterbutyl dicarbonate group. So we abbreviate that as this right here. Oops. And sometimes you run this in some sort of a base, just in case anything that gets broken off. And I just noticed, by the way, there should be an H right here. Anything that gets broken off from your diterbutyl dicarbonate doesn't pull off the H, or maybe it pulls off like 70%. You could throw in something like a triethyl ether. And usually that gets the trick done. What this looks like when you're able to do this first step, you just replace that proton with the BOC group. So in the second step, well, now that the amine is protected, we can start playing with the alcohol and doing things with there. So I think the easiest thing is just to recognize that if we oxidize this in step 2, then we can attack it with a nucleophile, oxidize it again, um, and then if our nucleophile was something that already had this group on it, that'd be essentially the um, the end of the synthesis. So I'm going to oxidize it with PCC. And I don't want to do it all the way with like Jones reagent or chromic acid, because doing that would bring us to the carboxylic acid, and carboxylic acid wouldn't be as easy to manipulate in this case. So here's what we'd have. That H is still on a wedge, and now we have an aldehyde. From this point, we can either use an alkylithium or a Grignard reagent to attack that carbonyl. So I'm going to make my Grignard reagent be the stuff that is hanging out right here. So how many carbons is that? That's 1, 2, and a third. So 1, 2, there's your third. I do something like that, and we can kind of just get ahead of ourselves real quick and know that the fourth step has to be acid. So any acid protonate. What step 3 and step 4 would look like. Step 3 and step 4. And our amine is still there, would look something like this. And so at this point, we're just about finished. We just have to figure out what 5 is. And we know that we can put in another oxidizing reagent. So again, we could use PCC, or in this case, you could use Jones or chromic acid, and that would work just fine. So I'm going to say PCC, and I'm just going to write product. So here's our second problem. Go ahead and give it a try real quick, and then we can talk about it after. So if you went through this and you realize it was kind of easy or strangely not that difficult or short, I'd agree, because you could get this whole reaction done in just about one step or 1 or 2 steps. First step being that we obviously need to protect this carbonyl. It's nice that the other carbonyl is conjugated, do that double bond there, so we can use something like ethylene glycol and use one equivalent. And we know that it won't affect the conjugated carbonyl. So let's go ahead and do that. And of course, we run these ethylene glycol protecting groups with some acid. The acid's just supposed to initiate the reaction. So doing that gets us right here. There's that conjugated carbonyl we haven't moved. And that's where we attach the ethylene glycol. So the second thing we'll want to do is to reduce that carbonyl. And we know we can reduce carbonyls like that, so conjugate carbonyls, with the Raney nickel reduction. And so the Raney nickel reduction, I use that kind of thiol that looks very similar to ethylene glycol. So you use something like this. And they usually run it with some acid. So you could either skip ahead and say, I'm going to use a protic acid, or you can say that you're going to use a Lewis acid. And so if this was a case where you didn't want anything that was protic in solution, then you'd run like borane. So that's BH3. Um, if you run it with borane, then to get back to our product from number one, we have to get rid of this protecting group. But we do want something protic because we know that we are eventually going to get rid of this protecting group. So if we did that, so if we decide to go with this one, that'll let this be just a two-step synthesis. And so that's what I was getting at earlier in the problem. But, and then this is followed up by, so I guess I could write 2B, and I can say this is 2A. And that's followed up by the hydrogen and Raney nickel. So H2 and, oops, H2 and Raney nickel. And our final product will be exactly what is above in green.